Hello again, Niemeyer back at it. First name Mr. We're going to be going into surface area just like I did with volume for everyday objects. So let's dive right in. I'm going to start by finding the area of this pink rectangle of my Diet Dr. Pepper. Surface area is all about finding the area on all the surfaces of a 3D object. I know, crazy. Couldn't get that from the title. Anyways, let's dive right in. I'm going to measure again just so we're clear on how we're getting these values. Probably going to be the same numbers as they were for my volume video, but good way to check to see if I'm measuring stuff accurately. So let's start with the length here. Looks like it's going to be 26 centimeters. I'm going to write it up here just so I don't have to remember all of those all at once. So that's going to be 26 here for this length, and then the width here is 24 centimeters. 24. I could get the height, but I'm going to go ahead and get this area first. How do you find the area of this pink rectangle if this is 24 centimeters and this is 26? If you said multiply, you're absolutely right. I'm going to go ahead and use the old calculator on that one. 24 times 26 is 624. Okay, cool. So that is going to be the same area as the opposite side, right? Looks like I didn't do a very good job of covering the other side with pink paper, but you get the same idea, I think. It's going to be the same area as the other side, or it wouldn't be a rectangular prism. And that's why we have, for the first part of here, it says 2 times length times width. We found the area by doing length times width. We got 624. We're going to double that to account for both the front side and the back side. Okay? So 2 times 624, surface area. Okay, now for this next one, I'm going to need to find that height measurement. So that is going to be this one right here. And that is 20 centimeters. Cool. So now I can go ahead and figure out this rectangle here. So if I know this is 20 centimeters, and from the last rectangle we have, we know that this 24 centimeter side that I measured over here is going to be the same over here. So to calculate this blue side here, I have 24 centimeters by 20 centimeters. 24 by 20, I think, is 480 total. 480. And that means the other side is also going to be 480 square centimeters. So let's do plus 2 times 480. Okay, then the last part I need to measure is going to be that top one, which is this green one here. Now let's see. The measurements we are working with is, well, since I measured down here and that was 26 centimeters, that means this side of the green rectangle is also going to be 26 centimeters. And then this width here is going to be 20 centimeters from what I have up here, right? Because this measurement is going to be the same as what's up here. So I have 20 times, what is that, 26? 20 times 26, I believe, is 520 square centimeters on the top. And you're just going to have to trust me that it's the same on the bottom because I got thirsty and I already busted into this bad boy. So, we got 520 on top. We got 520 square centimeters on bottom. So that's 2 times 520. Now let's go ahead and calculate this all out. 2 times 624 is going to be, what is that, 1248. And then 2 times 480 is going to be 960. And then 2 times 520 is going to be 1040. Hopefully you can all see that. So I'm going to go ahead and plug that in. 1248 plus 960 plus 1040 gets me a total of 3,248 square centimeters. Cool. That's all done. Let's get that out of the way. Let's move on to the triangular prism one. I think this one's a little more complex just because you're dealing with two different types of shapes that you are finding the area of, but it's the same kind of concept. Let's go ahead and start with the triangle part. That's our base for this prism. So let's see. First, I'm going to find that area of the triangle, which is going to be, looks like 25 centimeters for the length. So if I'm following my formula written up here, I have 2 times 1/2 times, well, I said 25 centimeters. And then the width, which is kind of this side right here, looks like that is 4 centimeters. Let's go ahead and write these in so I can keep track of them all. 25, this was 4. Okay, length times width. Width I found was 4. Okay, cool. So the area for just this orange triangle, if I'm only counting for one of them, 1/2 times length times width, it looks like that's going to be, what is that, 50? 25 times 4 is 100. 100 times 1/2, or half of 100, is 50. So, not a lot of area to write that on. There we go. That's 50 there. And because it is a triangular prism, that means the other side is going to be the exact same area. So that's also going to be 50. So that's why we have this 2 in front to multiply it, because we know that the front and the back triangle are going to be the same area. Cool. So I am going to move on to the next shape. Let's do the green one here, this big ol' rectangle here. Now to do that, I need this measurement here, which is going to be this one, because that's one of the sides of this green rectangle. So let's see what that comes out to be. Looks like 28 for this one. And then I just need to measure the other side. I got this one as 28 centimeters, so I'm going to measure this one. That's kind of like the diagonal of the triangle. We didn't really need that for volume, but we are going to need it for surface area. So let's go ahead and do that. That is going to be, oh, looks like 26, so slightly longer than that bottom side. Notice I wrote 26 up here because, you know, it's going to be the same on this side as it is this one because it's a rectangle. Okay, so that means the whole area for this green rectangle here, the one on top, has to be 26 times 28, because that's how you find the area of a rectangle, and it is indeed a rectangle. 26 times 28, 728 square centimeters. Cool. I'm going to go ahead and write that one in, right? That's the height times the side length that I did here. Let's see, next I wrote width times height, which is going to be this side. Oh, it's going to be that back rectangle. Looks pretty thin, which makes sense because this measurement was only 4. Okay, so if this was 4, and let's see, my width is 4, my height is, oh, it's 28, right. We said that this length was 28. So we have 4 times 28 gets us the area of this rectangle. 4 times 28 gets us 112. Cool. We've almost got all the sides here. We only have one left, and that's got to be the bottom, right? So I made that pink, because why not? So let's see. To get that pink side, it looks like I'm dealing with these sides. If I'm holding it like this, I notice that 25 is talking about this side of the rectangle, and this 28, that height, was the other side. So I have 25 times 28 to calculate. 25 times 28 is going to be 700. 700. I think I got all 5 sides there. Okay, 700, good. Okay, so let's calculate this all out. I said 1/2 times 25 times 4 is 50. 2 times 50 is 100. So we have 100 plus 728 plus 112 plus 700. And I got 1,640. And I better put square centimeters because it is an area and I was measuring in centimeters. All right, cool. Done with the binder. Get rid of that. Let's move on to the last one. Surface area of a can. You can tell that I drank that one. Let's see. So first we got to find the area of the base, which in this case for a cylinder is a circle. Remember, the area of a circle is pi r squared. Pi times the radius squared. Let's go ahead and measure that radius. Now I like to do the diameter because it's a lot easier for me to find that rather than guess where the center of a circle is. And I'm getting 5 centimeters as the diameter. So if 5 centimeters is my diameter of my circle, what is my radius? Yes, that's right. Cut it in half to get 2.5 centimeters. Okay, cool. So surface area equals 2 times, what's pi? Yeah, 3.14 times 2.5 times 2.5. Oh, I'm running out of room. Why did I do 2.5 twice? Well, because that's what the squared means. It says you're going to take 2 radiuses, or rather radii, and multiply them together. So let's make that very clear. That's what I'm doing here. 3.14 times 2.5 times 2.5 gets me one of those circles areas. Okay, so 3.14 times 2.5 times 2.5 equals 19.625. But I also got to multiply that by 2. Why? Well, because the circle on top is going to be the exact same as the one on bottom. So I'm going to go ahead and write that in. 19.625. 19.625. Oh. Okay. So if I add those together, well, maybe I'll do that at the end. We'll do that at the end. Let's get that height first. Why do we need the height? Well, if you recall from the other video I made, this is really just one rectangle wrapped around the entire cylinder. So we need the height, which is going to be 12 centimeters. Okay. And then I also need to know that kind of bottom side length that wraps all the way around. That's kind of tricky because it's curved, but if you recall, that's going to be like the perimeter of the circle that makes up the base on the bottom, which you can find by calculating the circumference. How do I find that? Well, I got it right here. It's 2 times pi times r, or our radius. So that's 2 times 3.14. Let's make a little room here. Times the radius of 2.5. And then we throw in that 12 for the height. Oh my goodness. That's a lot to keep track of. Let's go ahead and calculate that out. 2 times 3.14 times 2.5 times 12. Woo! I got 188. Whoa, 88.4. And that's the area all the way around for all of that orange surface. All right, so now I just need to add that to the 2 circle areas. So let's do that as kind of a whole new calculation with new numbers. It's really the same calculation, but this is kind of crazy right now. I'm going to simplify it a little. Let's see, so we have 19.625 and that 188.4. I'm going to multiply the circle area we got, which was 19.625. And I'm going to add that to my rectangular area of 188.4. And then when I calculate that all out, well, 2 times 19.625 should be just shy of 40, which it is. It's 39.25. I'm going to add that to 188.4, and I get a final surface area of 227.65. 0.65 what? What did I measure these in? It was centimeters. Good. And then we're talking about area, so is it just centimeters? Is it centimeters squared? Centimeters cubed? Should be centimeters squared. Because every time we made measurements, we multiplied it to another one. Did you realize that? Notice up here, radius was multiplied twice. Centimeters times centimeters gets centimeters squared. Look at this one, radius times height. Those were both measurements made in centimeters. And you'll notice it's that way for all of this. Length times width, 2 measurements multiplied together. Height times the side length, or that diagonal line, 2 measurements multiplied together. Centimeters times centimeters is centimeters squared. If you go back to our volume videos, you'll notice we always multiplied 3 measurements. That's how we got centimeters cubed for that video. And you might say, well, we're multiplying more than 2 things. Up here, we're multiplying 2 and 1/2 and length and width. Yes, good point. However, 2 and 1/2 were never measurements made. The 2 was accounting for there are 2 identical sides for the area of the triangle in that instance. And the 1/2 we got because that is in the area of a triangle. So it's always multiplying 2 measurements. Anyways, I hope this helps a little. Use this to help you out with all those surface area problems. If you have any questions, again, reach out to myself or any of the math teachers. Until then, stay safe and keep doing that math.